Welcome back to Math Solver 1117, where we turn hard math into simple logic. If you are preparing for digital SAT, hit the subscribe button because I post past paper solution and high yield tips to maximize your score. Digital SAT math on 8 March 2025 was full of surprises, tricky word problems, algebra traps, and time pressure. But don't worry. In this video, I am solving every question step by step with smart shortcuts you can use on test day. Stay tuned because at the end, I will reveal 3 secret strategies that top scores use to hit 750 plus. Now the question number 1 is the equation r square plus qr equals 8r minus 69 where q is an integer constant. Find the largest possible value of q. So we will solve this question in a very easy and simple way. First of all, here is the power r square then r power 0. It means this equation can be converted into standard quadratic equation. So we will get r square plus qr minus 8r plus 69 equals 0. Now we will convert this in standard like ax square plus bx plus c equals 0. This become r square plus q minus 8 into r plus 69 equals 0. So from this we get the value of a, b and c as a equal 1, b equal q minus 8 and c equals 69. So we will apply the condition for no real solution. Now for this purpose we will apply the condition that is b square minus 4ac, the discriminant is less than 0. This is the condition for no real solution. Now we will substitute all the values in this. B square means q minus 8 square minus 4 into value of a is 1 and c is 69, that is less than 0. So we get q minus 8 square minus 69 into 4 is 276, that is less than 0. So when we solve this further, we will write this as q minus 8 square less than 276. Now we take the square root on both sides and get q minus 8 square less than square root 276. This means that we will write mod of, now we will put the square root value plus minus. For this purpose we will put q minus 8, mod of q minus 8 is less than 276 square root. Now we will take the approximate value of square root 276 with the help of calculator. So we know two conditions that we will use here, that two condition. 16 square is basically 256 and the 17 square is 289. It means we have the value 276 that will be lie between 16 and 17. So we will take the approximate value of this. So the approximate value of q minus 8, that was less than square root 276, and approximately square root 276 equals 16.61. So which shows that we will write the value as minus 16.61, that will be less than q minus 8, and that will be less than plus 16.61. Then we will add 8 on both sides to get just the value of q. So minus 16.61 plus 8 less than q minus 8 plus 8, 16.61 plus 8. So we get the final answer as minus 8.61 less than q, that will be less than 24.61. So this will be the final answer. You have to determine the largest value. So q must be an integer, then q will be less than this. So this will be the largest value of q, possible value. I hope you understand how I have solved question number 1. Now I will solve question number 2. Now the question number 2 is, if 4a by n equals 3.5 and a by bn equals 14, where a, b and n are the constants, you have to find the value of 1 over n. So we will solve this question step by step. Given equations are, we have 4a by b, that is 3.5, and the a by bn, that equals 14. So we will substitute the value of a by b in this equation by taking this will be the equation 1 and this will be the equation 2. So from 2 we have a, b, n, that equals 14. It means we have to find the value of 1 over n. That implies that b is divided here, it will be multiplied, and a is multiplied, it will be divided. So 14 b by a. Now from this equation, this is from 2, and now from 1 we have to find b over a value. So 4a by b equals 3.5 and we have to find the value of b over a. It's mean cross multiply b over a, that will become 4 divided by 3.5. So this will be the b over a, and we get, now we will substitute this value in this and get 1 over n, that equals 14 multiplied by 4 divided by 3.5. So multiply this by 10 to eliminate this decimal. We have 5 2s are 10, 5 7s are 35, 7 1s are 7, 7 2s are 14. So 1 over n equals 2 into 4, 8, 8 into 2 is 16. So our answer is 16. So this will be the answer. Now we will solve question number 3. Now question number 3 is, in triangle PRN, PN is 111 inches and side RN is 113 inches. Find the PR. We will draw this diagram first. Let's consider this is P, this is R and this is N. And length of PN is 111 inches and RN is 113, and you have to find the length of this. So we cannot find the exact value. We will use the trick to solve this. So we have two conditions. First of all, one side is 111. So 111 plus 113 we will get 224. And the second one is subtraction of both. So this is equal to. So third side will be lies between, let's suppose third side equals x. So that is not less than 2 and not greater than 224. So this will be the final answer. Now the question number 4 is f of z equals z plus 8 into z plus 8 minus 25 r square minus 775. Our solution is z equals minus 88 where r is the constant. What is the value of r? So we will solve this question in a very easy and simple way. First of all, just substitute the given value of z, that is minus 88. So this is the solution. Its mean f of z will be equal 0. We will write this as at z equals minus 88 implies f of minus 88 equals 0, because this is given condition that this is the solution. So we will solve this further as 0 equals minus 88 plus 8 minus 88 plus 8 minus 25 r square minus 775. So we have 0 equals minus 80 into minus 80 minus 25 r square minus 775. Minus minus plus 80 into 80 will be 6400, and 6400 minus 25 r square minus 775, that equals 0. So this implies that 0 equals minus 25 r square, and 775 subtracted from 64 we will get minus plus 5 and 2 6 5 6 2 5. Now we have to find the value of r. Now we have 25 r square equal 5 6 2 5. Then we will solve this as r square equals 5 6 2 5 divided by 25. So this will be equal to 25. So by taking the square root on both sides, we know that 225 is the square root of 15. So we will get r equals plus minus 15. So the value of r will be this. So this will be the final answer. If you found this video helpful, subscribe Math Solver 1117 and also hit the bell icon to get notification for all upcoming videos. In the next video, we will solve the remaining question of this digital SAT math that was held on 8 March 2025. Stay tuned. Best of luck for your exam.